Hello, good afternoon, friends. My name is Darshan Patel. Today we will study most important topics for automobile system design, spring design. Do you know what is a spring? Spring is generally defined as, if you can say what is a spring, then spring can be defined as it is an elastic body whose function is that to distort when loaded and to receive to its original shape when the load is to remove. What is the main application for the spring? Anyone say? The main application for the spring is that to apply the force in the clutch brakes, to measure force, whether spring balance force, to store the energy in clocks, toys, and to absorb shock and vibration. Next is types of spring. There are many different types of spring. First is the helical spring. Helical spring is spring can be located in the helix shape. In helix shape, most important topic, most important thing is that is spring can be connected in the form of the helix angle. In this helix angle, based on this helix angle, based on this helix angle, there are different closed coil helical spring and open coil helical spring. In the closed coil helical spring, helix angle is the less than 10 degree and open coil helical spring is greater than 10 degree. Here is the helical spring, here is the tension spring. Another thing is that this is the conical and volute springs, this is a torsion springs, this is a disc spring, it is also known as a bolero springs. This is a leaf spring, generally it is used in the automobiles vehicles. Most time we think is that for example point of view is the different terms can be used in the compression springs. First is the solid length. What is the solid length? The solid length is the compression spring. It is compressed until the coils comes in the contact with each other. Then the spring said to be solid length. Solid, it means Ls is equal to N dash into D, where N dash is equal to total number of the coils and D is equal to wire diameter. Second thing is the free length. Free length, it means the length of the spring in the free or unloaded condition. Here it can be plotted the free length. Here free length can be find out, can be the equation is that LF is equal to solid length plus maximum compression plus clearance between the adjacent coil plus clearance plus allowance. LF is equal to N dash D plus del maximum plus 0.15 delta maximum, and when the clearance can be provided, then this equation is LF is equal to N dash D plus delta maximum plus N dash minus 1 into 1 mm. This is the free length. Another thing is that this is spring index. What is a spring index? It is a ratio of the mean diameter of coil to the wire diameter. C is equal to capital D by D, where capital D is equal to mean diameter of coil, small d is the wire diameter of coil. Spring rate. Spring rate is defined as a load per unit deflection, W by delta, where W equal to load and delta equal to deflection. Pitch. Pitch is equal to LF upon N dash minus 1. It means axial distance between adjacent coil in the uncompressed state. Another equation for the pitch is that P equal to LF minus LS upon N dash plus D, where LF is equal to free length of the spring, LS solid length of the spring N dash total number of coils and D equal to wire diameter. Next is the stress in the helical coil spring in the circular wire. When the wire in the circular form, in this way the helical spring can be used. There is a two types of stress can be generated. One is a twisting stress, another is the bending stress to the crushing stress. Here twisting moments T is equal to W into D by 2 equal to pi by 16 tau D cube. It means we can generate a shear stress tau 1 is equal to 8 WD upon pi D cube. In addition to that, the torsion shear stress tau 1 is induced in the wire. Following stress can be act on the wire. Direct shear stress due to the load W and a direct stress to the curvature wire. Two types of stress can be generated according to the wire and according to the curvature effect. Based on the wire and based on the curvature effect, two types of the factor can be generated. We will see in the next session of the topic. The direct shear stress due to the load W is equal to tau T is equal to W upon A, W upon pi by 4 d square, it means 4W upon pi d square, it is equation number 2. This is entire plot diagram for the shear stress generation for the torsional effects and crushing effect, with clearance and without clearance, with the curvature effect and neglect the curvature effect. So total resultant stress induced in the wire is that tau is equal to tau 1 plus or minus tau 2. It means 8wd upon pi d cube plus or minus 4w upon pi d square. Here positive sign can be inner edge for the wire and negative sign can be used for the outer edge of the wire. It means stress is maximum is the inner edge of the wire coil having diameter small d. Next is to show the maximum shear stress induced in the wire is mean torsional shear stress plus direct shear stress. It means 8wd upon pi d cube plus 4w upon pi d square is equal to 8wd upon pi d cube in the bracket 1 plus small d upon 2d. It means हम लोगों ने क्या किया है इस इक्वेशन में 8wd upon pi d cube कॉमन निकाले हैं तो क्या आएगा 1 plus 1 upon 2c into 8wd upon pi d cube where c क्या where 1 upon 2c where c है capital D upon small d. It means tau is equal to Ks multiplied by 8wd upon pi d cube, where Ks is the shear stress factor, most important factor for the numerical solving, where Ks is equal to shear stress factor is equal to 1 plus 1 upon 2c. In order to consider the curvature effect, when we have to consider another factor, it is known as a Wahl's factor. Wahl's factor tau is equal to K multiplied by 8wd upon pi d cube. It means K multiplied by 8wc upon pi d square, where c is equal to d by d. Where Wahl's factor K is equal to 4c minus 1 upon 4c minus 4 plus 0.615 by c. This is the curvature effect diagrams. So Wahl's factor versus spring rate. Where Wahl's factor can be calculated by the Ks multiplied by Kc. If in the example, if Ks and Kc can be given from this equation, we can calculate also Wahl's factor if spring rate is not given. Where Ks is equal to shear stress factor due to shear and the Kc is stress concentration factor due to curvature. Okay, you understand that what is a spring, what is the spring index, what is the shear stress theory, what is the Wahl's factor. And another thing is that now we will see the some deflection of the helical springs of the curvature. With curvature, without curvature, of circular wire. Means let the total active length of the wire L is equal to length of the one coil multiplied by number of the active coil. It means L is equal to pi d into N. Where theta equal to angular deflection of the wire, axial deflection spring, it means delta is equal to theta into d by 2. It is equation number 1 हम लोग लग रहे थे. For T upon J is equal to Z theta upon L is equal to tau upon d by 2 for the shaft. From this equation we can subject to the angular deflection theta equal to TL upon Jg, where J is a polar moment of inertia for the spring wire, where J equal to pi by 32 d raised to 4. G is the modulus of the rigidity. Tau, from this equation tau is equal to TL upon Jg, we can substitute the value of the T, L, J and G. And when we can get equation for the theta equal to 16w square d square dn upon Gd raised to 4. We can find out the deflection delta is equal to theta into d by 2. So we can substitute the value of theta in the deflection equation. So delta can be given as 8w d cube n upon Gd raised to 4. It means 8w sec cube n upon Gd, where c is equal to capital D upon small d. The stiffness of the spring, it means spring rate is K is equal to W by delta. It means Gd raised to 4 upon 8d cube into n. It means Gd upon 8 sec cube into n. It is a constant. It is not any unit, it is a constant. From this equation we can find out the delta. It is a most equation for the examination for the numerical solution. First equation is for delta. Delta equal 8w d cube upon Gd raised to 4. It means 8w sec cube n upon Gd. And another equation for the shear stress factor is that tau equal to K AWC upon pi d square, where K is Wahl's factor, 4c minus 1 of 4c minus 4 plus 0.615 by c, where K is Wahl's factor. And when without curvature, tau is equal to Ks into 8wd upon pi d cube, where K is shear stress factor 1 plus 1 upon 2c. Now, from the next lecture, we will solve the numerical solving for the spring index. How we can design the helical spring, coil spring, leaf spring. Okay, thank you.